Hello, my name is Miracle Chibuzo Marcel. I am the founder and the director of the largest citizen science community in Africa called the Pan African Citizen Science E-Lab. So, in this in this program, I'm going to be talking about our project and our achievement over the past 3 years. So in table of content, I will be introducing PACS Lab, our key project, and our results. So PACS Lab was founded in December 4th, 2020, and our aim is to promote hands-on activities in astronomy and space science through citizen science and soft astronomy research in Africa as a means of advancing space exploration and enhancing space education and outreach. So, and how we do that is by collaborating with entities in the global north and bringing those opportunities to Africa. And all our activities are online. All our activities are based online. So here is your official logo showing the map of Africa. Here you can see individuals with their computers or phones are analyzing and reducing space data. And that is exactly what we do. We also have a WhatsApp group where we interact within our community. So for the general requirement, all particular projects are suitable for all individuals regardless of age, religion, country, sexual orientation, academic or professional affiliations, levels, etc. So to participate in our project, what you just need is to have a basic knowledge of computers, most especially Windows operating system, internet, and passion for space. Now, in our organization, we have different kinds of projects classified as primary project and secondary project. The primary project are our main projects, and I'm going to be describing them one after the other. So the first of our primary project is the Pan-African Asteroid Search Campaign, and we collaborate with the International Astronomical Search Collaboration. We are their biggest partner in Africa. And in this project, we contribute in in planetary defense through discovering new asteroids. We submit the report to the Minor Planet Center so that the orbit of these asteroids can be classified and continuous monitoring can be done in order to avoid events like this. We use the astrometrical software to analyze the images. Here you can see there are about 4 images taken at different time intervals. Here is the blinking windows that blinks the images in order for you to see if an object is moving or not. That is how we detect asteroids. The data we use are gotten from the Penn stars located at the University of Hawaii and the Catalina Sky Survey located at the University of Arizona. Now, in this chart, there are uh, there are more surveys around the world observing the sky, scanning the sky, and taking data, asteroid data. But these two are the are the most. They collect the most asteroid data, and now they have automated system in them that detect this asteroid. But not all of these, not all of these asteroids are detected. So they send the data those data to the International Astronomical Research Collaboration so that we can use the manpower to discover these asteroids. So we are part of them, the Pan-African Asteroid Search Campaign, and here we engage different entities across Africa in the asteroid search campaign. So here is just one of our groups, the Amateur Astronomy Libya. So this is where the teams we download the data, analyze the data, submit it through here. So this is just the demonstration. So for the tools to participate in the asteroid search, our participants would need Windows operating system, internet, and Astrometrical. Astrometrical is a free software. Now, in training, we have recorded videos in English, French, and Arabic. And here is just one example of one of my recordings in English. We also have Arabic and French. We have some of our members volunteer and develop those videos in other languages too. We also conduct online training via Zoom. So far, we have discovered 32 asteroids, and those asteroids were discovered by about 60 of our citizen scientists. However, we still have hundreds of preliminary discoveries that are yet to be confirmed. So here is the academic calendar for the new academic year. We started this August. It runs every month till May. That is how we conduct it every year. So here is our second project, Exoplanet and Photometry, and we collaborate with NASA Exoplanet Watch. So in this research, we contribute data. We contribute data in order to refine the mid-transit period of already discovered exoplanets in order for the future missions like the James Webb Space Telescope to study them again and in details in order to detect if there is life or no life in them. But the reason why we are doing this is because when these exoplanets were discovered by the Kepler and the TESS missions, their periods were not accurate. So we are actually redefining their mid-transit time in order to improve their period. So reduce we reduce the data with exotic software to produce this light curve. And after that, we submit the report to the American Association of Variable Star Observers. To participate in this project, we have three sources of data. Through the Exoplanet Watch website, you can request data directly from NASA. They would give you data if you submit your email there. We also have access to the Micro Observatory. There you can schedule your own missions. You can observe stars, okay, using the Micro Observatory. So this is the process of scheduling, and after requesting it, the micro observatory is going to turn around to focus on that spot. We also use the Los Cumbres Observatory for observation. We are part of the Global Sky Partners of the Los Cumbres Observatory. We have about 100 hours of observation time for our research and other endeavors also. So the tools for this research: any operating system, internet, Gmail. Gmail, not email, because this exotic program is a Python program and it is mounted on Google Colab. So to be able to have access to it, you need a Gmail. And all the software is online. For the training methodology, we have recorded videos. I also offer online training via Zoom. And here's an example of the recorded video. So in this project, our aim is to make our citizen scientists to contribute to peer-reviewed publication in order to enhance their academic and professional status. But being citizen scientists, they do not have advanced a level of astronomy in order to carry out professional astronomy research. So we sought for some research they can do without advanced knowledge of astronomy, and one of them is on double star research. We collaborate with Dr. Richard Fried, the president of the Institute for Student Astronomical Research in the United States. And in this research, what we do is to update the position angle and the separation of these double stars. We also verify if they are binary stars or optical double stars. So the students write papers, they write manuscripts on their findings and submit to the Journal of Double Star Observation. So far, we have written since this year, 2024, we started this year, we have written up to 12 manuscripts, but 4 have been published. So in the training methodology, we have recorded video like this and online interaction with the research instructor. For the tools, you can use any operating system. You would need internet, you need ASO imagery and other programs. Then we have radio contact to ISS with amateur radio on the International Space Station. This opportunity is going to allow our African citizen scientists to interact with astronauts aboard the International Space Station in order to ask them questions. This is a project that is usually seen in advanced countries. However, entities in South Africa and Morocco also conduct this exercise, but we are the first organization that is going to bring it in the African society, and we hope to make it permanent. So here is an AI generated image of how the event is going to be. The students are going to interact with astronauts via Zoom, and we are getting prepared to conduct this starting from 2025. So in the astrophoto visual development, we teach our citizen scientists how to process space images to produce colorful visuals. So we teach them how to process images from the Hubble Space Telescope, the James Webb Space Telescope, and the Los Cosmos Observatory. So for the training methodology, we have recorded videos, we have online training via Zoom. We have Photoshop training, we have GIMP. So in our telescope giveaway program, we collaborate with GNP Groded and AFERS in distributing telescope across Africa. And the purpose of doing this is because we are working with a whole lot of teachers across Africa. And some of them, they need this telescope for their teachers training program. So we collaborate with this organization to distribute telescopes to them. Another purpose of this telescope giveaway is that there are some countries in Africa we find it so difficult to recruit citizen scientists. So it means that the astronomy knowledge in those places are very low. So when we find somebody from that place, we give that person telescope for astronomy outreach in order to spread astronomy and also to recruit citizen scientists. Live observation. Live observation via Sloop Webb telescope. So we use the Sloop telescope for live observation. Here is the dome. We use it to observe the moon, the sun, live. Okay, live observation, not through email. Live observation. We can also use it to observe deep space images. And most importantly, we use it to observe eclipses. Like this is the pictures. These are the pictures from the eclipse that happened in North America in April of this year. We're observing it right from Africa while it is happening in America. So here is the map of the world showing the different places in the world where the Sloop telescope is located. So they have location in Chile, they have location in Canary Island, and they also have location in Australia. They also have mobile telescope. They move around the world for eclipse observations. So in order to evaluate our result, we issued surveys to our group leaders in order to know how they are adopting our project in their classroom. So from the survey, we got that 691 citizen scientists have been engaged across 45 countries in Africa. Mind you, there are about 54 countries in Africa, so 45 out of 54 countries have been engaged. Now, we have about 70 groups. We work in groups, we don't work individual, we work with groups. Now, out of those 70 groups, we classify them according to levels. For instance, A is equal to 15. A represents national space agencies, national astronomical societies, national observatories, and other national entities. B is equal to 25, representing university groups. And C is equal to 30, representing private astronomy organizations and also including secondary schools. So here is the gender identities. Most of the people that fill the surveys identified as male and female. Levels of education, we have secondary schools, we have bachelors, we have masters, we have PhDs. So from here you can see that bachelors have the most participation. And for these PhDs, the PhDs are mostly university researchers and lecturers adopting our project in their classroom and engaging these students. So our particular project, the four active ones, from the survey, we discovered that the asteroid search is the most pronounced, although others we recently incorporated them. However, the asteroid search has been with us since the past 3 years. So here is the year of participation of citizen scientists. We started this program in 2020, and the number we keep recruiting people. The number have been increasing every year by year, and we are in 2024. So there are five geographical zones in Africa. So here are the population of citizen scientists from each of these geographical zones. So here is a map of Africa showing the countries where we have expanded our network. The countries in blue are the countries who have expanded our network. We are still looking for participants from Mali, from Mauritania, and Cape Verde, and other countries. So our project has been contributing to 6 out of the 17 um, SDG goals, Sustainable Development Goals, which are quality education, gender equality, decent work, and economic growth, gender inequality, reduce inequality, peace, justice, and strong institution, partnership for the goals. So we have written papers on about our organization, and also we are writing papers on each of our projects. So far we have written 2 and we are still writing more. So if you want to read everything about our organization that I have just explained now, I want you to go to our website and go to the publication page so that anytime we drop any paper there, you can have a look at it. You can also sign up for our newsletter so that you can receive a notification when the papers are ready. They are still undergoing peer review. So we are looking for collaborators across Africa and beyond. We are looking for collaborators. So if you are interested in collaborating with us, please reach out to us. Thank you so much.